opportunity to share our learning with the community. Today I am going to speak about INFER. INFER is a platform which enables Edge ML on Dream11 app. Next slide. So before delving deep inside INFER, let's try to first understand what Edge ML is. Edge ML is a technique to actually run a machine learning algorithm on mobile device. So over the years we have seen multiple application of Edge ML on the mobile device. You have OK Google on your Android devices. Then these kind of suggestion that you get on the keyboard is powered by ML on mobile device, and the facial detection on our cameras are basically powered by ML device. So Dream11 also have, like, if you can see that all these use cases have one thing in common. A user cannot wait for server turnaround time to
I'm sorry,
actually.
I can't find any information about Android devices in your home.
Okay, yeah, so all of these use cases have one thing in common. A user cannot wait for like turnaround time from the server. The computation needs to happen on device. So in Dream11 we also have such use cases where we want to run ML model on device, where we can't wait for the server turnaround time. One of the use cases is contest recommendation that we do once any player joins the contest. How many of you have played on Dream11 app? Show of hands. You guys are part of the team. Come on. So like let's say you create a team on Dream11 app and you try to join contest on Dream11 app. So when you join a contest, our users have a tendency to join contest around the match startup time. So that time, once a user joins the contest from the recommended contest section, we want our users to recommend contest in very real time. It's very critical for our business. So those kind of use case cannot happen on server because we have so big user base that we cannot create recommendation in real time on the server side. It's going to cost us lot of infrastructure, and the latency there would be very high. So we will see the numbers in like how much time we are actually producing the recommendation on mobile device in later slide. Next slide. So these are like major benefits of ML on edge. One is reduced latency that we have already spoken about. So if data privacy is concerned for you, then the data for which the ML model is run is like residing on the mobile device only. It's not flowing on the network to this cloud. So the privacy is taken care out of the box, and it gives you cost effectiveness because you are actually using the mobile device to do the model computation. So none of your server cost is taken out of your budget. And if you want to provide offline experience to your users, and in that offline experience you want to provide ML, like if you in the offline experience, if you want to provide some ML functionalities, this is the only option that you have. Yeah, but whenever you try to ship your ML experience to the user base, and if the user base is huge, these are the challenges that you face. Like as you can see, for the Dream11 users, like a major chunk of our users are using low-end device. A lot of users have low RAM, a lot of users have like a very poor CPU. Another challenge is like we serve our app to a huge set of plethora of device models, around 19K of different models that you serve, and we need to ensure that the model which is created runs on all the device. It doesn't crash the app. So whenever you are trying to run the models on mobile device, you need to take care of the model size. Generally these models are developed on a huge data set, and by default the size of models are of the order of hundreds of MB. To load those models in on device memory, as you saw that most of our users are on 2 GB RAM device, you need to ensure that the model size is low. So to reduce the model, while reducing the model size, the accuracy takes a hit. So you need to strike right balance between accuracy and the size of the model. Lastly, the whole model development the ownership of the whole model development is with the ML scientist team, who looks at the data. They train the ML algorithm on the huge data sets. They create the model, but whenever they try to deploy the model on the application, they actually needs to do the integration in the app, and there is no tool for data scientists to actually ensure that the model that they have created is compatible with the given app version. And while integrating the model within the app, there needs to be a lot of application code to be written, and for that they rely heavily on the front end engineer, and the front end engineer integrating that model into the app needs to have some ML knowledge, and becomes like a very like the curve of learning that is steep, and that leads to inefficiency in the system. Third is model delivery. There is no tool right now which ensure that the model that getting delivered on the client. If let's say the model is download of model is failed on the client, there is no tool to ensure that the retrial happens on time, and is tracking that these many devices doesn't have the model downloaded. So in order to solve all these issues, we have created a platform called INFER. Pawan will help you walk through the functionalities that INFER provide. Pawan.
Yeah. Thank you, Shri. Hello, everyone. I'm sure you guys are really interested to know more about INFER, like what this platform offers and what are the challenges that Shri just mentioned, how we are tackling and solving those challenges for two different personas. Like one persona is for users, those are ML scientists, and secondly, the front-end engineers who wants to run the machine learning models with easy to use APIs. So on a high level, if you see, we have two modules on INFER. One is INFER dashboard. INFER dashboard is for users, like for ML scientists, where they can seamlessly deploy their machine learning models on edge with very less support of front-end engineers. They have the end-to-end testing frameworks built with the INFER dashboard itself. Second high-level module is a React Native SDK that is a part of our INFER platform, where front-end engineers can use the SDK and can use the React Native APIs to integrate their machine learning models, can use the prediction algorithms very efficiently. So I'll walk you through about these components in subsequent slides. INFER dashboard, like first of all, like as Shri mentioned, that we have faced challenges while working with data science team, that they always, once they create a machine learning model, they always need help from the front-end engineers to deploy their models, to test the machine learning models. For that, they need significant amount of time. Then they come up with the accuracy and model size challenges. They have to retrain their models again. To solve such challenges, we have created a dashboard for data scientists, where they can select models available in the model registry. You can think of model registry as a NPM registry, where like lots of machine learning models are already being created. Then we have also provided some sort of configurations under the INFER dashboard, where data scientists can define the schema for the data stores they want to have, and they want to do feature computes or want to process on the inputs. And similarly, they can also write some logic. For example, they want to do some pre-processing or post-processing before they start inferencing, or that they want to transform the output in such a way front-end engineer can understand. They can write their that pre-processing and post-processing logic in their favorite language. Right now we are supporting SQL, but in future we can support Python, like as part of INFER dashboard. And once this is done, they can optionally write some test cases and can deploy their machine learning models, and can do do testing. The testing frameworks ensures that the machine learning model, if it goes into the app for that specific app version or for that platform, it won't break the app. This sort of guarantee is provided by the INFER dashboard. Next, I will just walk you through the glimpse of INFER dashboard. This is the screen of deployment creation screen, where the team can select the model that they want to deploy, can choose a version. They can add the pre-processing and post-processing logic in the feature compute as part of in SQL. They can optionally upload the test suite that they want to run for the testing framework. They can add the events for the users activities. They can also specify the platform on which they want to deploy the model and for which version they want to deploy it. This is for that.
This event table is basically this is the information that is baked into the bundle that which events or user activity that this model should subscribe on, so that the feature compute logic works on those kind of events.
Okay.
We'll discuss in detail about how this whole thing works.
Once they create a deployment, they can see the deployment list here in the dashboard itself. They can go to the details of this deployment, like it is deployed or not, it is live, what is the status of it, what is the testing status of it. They can clearly go into the detail of the deployments. Okay. The next important module is the INFER React Native SDK. This is SDK, basically it is powered by the Onyx runtime right now. We have also explored runtime like TF Lite, PyTorch as well, but for our use cases we found Onyx is better for at that time, so we went ahead with the Onyx. To store the events or user activities in the user devices, we have used SQLite from Android. Okay. Now I will walk you through the offerings that INFER SDK provides. One key offering is model and runtime over the air delivery. So the INFER SDK itself contains a downloader that take care of downloading the machine learning models from the cloud and can save onto the device. Additionally, while we are working with the machine learning model runtimes, we have seen that the size of these runtimes are really huge, like 10 to 15 MB. So we don't want to take a hit on our APK size. So we thought to download the runtime also over the air. Like for that we use dynamic feature module and downloading the SO files over the air, so that we don't increase our app size. Second key component is the model runtime. Model runtime is basically to load the model into the RAM and run the predictions from the inputs for the given model ID. Next is data store module. Data store modules take care of storing all the user activities in the store, on which data science can write compute logics, pre and post processing logics, and can extract inputs for the model. Next is pre and post processing engine. Like as data scientists can subscribe to some of the events, those are stored in the data store. On those events or those user activities, they can write like the logic that they have shipped with the machine learning model. The logic is written in SQL only. The engine takes care of running that SQL logic on the data being stored in the data store. Can with this engine itself, they can extract out the inputs for the model and can feed to the model. Next is the feature store sync service. Additionally, this SDK provides the service that keeps syncing the features. Features you can understand as an input for the model. From the backend service, these are the inputs, those are global in nature. Like for most of the users, they might be same. So we don't want to recompute the global features into the device only. So for that, we have built a service, feature store service, that can keep syncing with the backend store and can store in the user database in the form of vectors and directly can be fed to the model. Now the second user persona that we have talked about, the front-end engineers, we can we have built the React Native SDK for INFER that front-end engineer can install directly, and they just need to get the instance of INFER client. To initialize the INFER client, they just need to call init function with the model IDs that they want to use. Internally, this API downloads the model from the cloud and also downloads the runtime that we talked about, like Onyx runtime or any of the runtime over the air, and can save into the device disk space. Then another API is load model. Once the model is being downloaded on the device, the front-end engineer can call the load model API to load the models from the disk to the RAM memory. Another API is for predicting. This is the API where prediction comes into the picture. Once the model is being loaded into the memory, they can call the inference for that particular model ID and the input that they want to give to the model. Last but not least, the destroy function, where as Shrey mentioned that we have lots of devices and we want to cater for the devices with low configuration, like less than 2 GB of resources. We see that machine learning models, when get into the memory, it takes around 500 MB of space. Once we can also, once the job is done for that model, we can destroy that model from the memory. So that's why we have kept the API as well to destroy the machine learning models from the RAM. As you can see, I have just explained the asynchronous API for all these SDK, for this SDK, but we've also kept the synchronous API as well. It's up to the choice of developer, like for which use case, for which type of API they want to use. They can use synchronous API, they can use asynchronous API as well. I think next Shrey will cover about the INFER use cases that we have
So
powered.
INFER is live within the Dream11 ecosystem, and right now it's there are like two major features which are powered by INFER. We spoke about contest personalization. These numbers are going to increase. Right now it's exposed to 6 lakh users, and the median inference time it takes is 335 ms. As compared to the network latency, if you are on a Wi-Fi network, the latency are of orders of 100 of ms. It is very less as compared to that. And we have another use case, deposit amount personalization. It is the amount which is suggested to the user when he tries to add cash into his wallet. So that is also a very critical piece for us, because most of our users actually deposit money through the contest join flow, and as we spoke that the contest join also happens very close to the match start time, and it is very critical for us to like keep that journey unhindered for the user, to have like a seamless experience. So we strive to suggest like a right amount that the user needs to deposit to make that contest join work. There also we are using an ML model which suggests that based on what is current balance, wallet balance is, what is his history of what kind of contest does he join, how much amount he would need for this match. Basis on all these input parameters, a model suggests a right amount the user needs to add into his wallet. Here also there is a median inference time is around 30 ms, and this load time is basically what Pawan spoke about, is like loading the map, loading the model from disk to the RAM memory. This happens while we start the app. This happens in an asynchronous way, so it doesn't impact our app startup time. What's ahead in 2025 for INFER? Firstly, we are going to open source it. I think Mayank spoke about it a lot. We are going to open source it under Dream Sports Lab, like any other project we have. Second is we are going to add generative AI capabilities like text to speech into the system. And we are also dabbling around with the idea of running a small language model on device for powering localization and translation on the app. Third is on-device training. So Onyx runtime that Pawan spoke about provides the capability to train your model on device. This is on the current usage pattern. So we are like currently evaluating if this can add any value to our business, and if we find out like enough revenue, we will invest in training ML model on device. Yeah, this is Dream Sports Lab. Guys, just scan this code and give star to this organization and follow it on GitHub. Yeah, and we are going to open source a lot of projects in 2025. One is INFER, second is SDUI, as Mayank mentioned, and we are already maintaining React Native Fast Image through Dream Sports Lab. Yeah, this is it. Mayank, anything you want to cover in this slide which I missed?
I think I covered all of it.
So the INFER team is actually here. We have Ravi, Nishant and Atharv, who has like extensively worked on this. You guys can connect with us or them after this talk. Yeah, thank you.